Yes. Okay. Okay, students. Good morning. So today's session, if we are going to find out or discuss another one more important the searching technique that is called as an DFS. That is a depth first search. Suppose here already we have discussed the breadth first search. So here the single branch of the tree has to be expanded. So finding the routing node of the hotel. Suppose if you can start from one route and then continue it until if you come to know you are at the hotel, or you have to change the path, or if you are not lead to the destination or the dead end. So so in case of you may think of or going back at some point and taking up some other path that can lead to you to the place. So this is called as in backtracking. Suppose if you are finding some other path, okay, so but if you are choosing some of the path, but this path does not find out or does not be able to find the goal state. So that's what that is. We are again come back to the original position, and then we need to find out some other path to find out the solution. This is called as an backtracking. So you just work it out, and here one of the a major data structure as it is stack has to be used to that is commonly used in the implementation of DFS. You just note down this. So this is a first step. Another one more thing is that so in the depth first search. So what in by depth first search? So here we are able to formulate the three important points. One is this: if the initial state is in final state, okay. So you just check whether whether the node has to reach the target node or not. So if it is reached, so you just success and then exit the process. Suppose if you are not if you are not getting this, or do it till you get the success or the failure, na? So again we need to find the successor. If there is no more successor can be generated, na, then there should be a failure. And go to the step one with the initial state with the current generated successor. So we may have the two different option. One is if the initial state is the final state, then success and exit. And second one is do it till you get success or the failure. So generate the successor. If no more than successor has can be generated, then failure. So this is the first step. We are going to find it. So next one more thing is the important aspect is an example. So how we are going to find out then example. So this is a one simple example. So how the DFS will work it out. So here so the searching technique has to be executed up to the depth level of the process. So we are able to find out, or if we are going to perform the operation up to the depth end of the process or depth end of the nodes. So you need to consider that kind of aspect. So you need to consider, for example, if you are starting this node. If you are starting this node as zero, or zero means, so again we are able to find out the successor. And again if you are moving down, and again this process has to be reached at the end of the process. Once if it is reached, or there is no further find out where there is no option to reach the final state, or there is no option to get the solution from the nodes. No? So again we go back to the previous question, and we need to find out some other alternate path to reach the destination. So this is a way we are able to find out for finding the solutions in the process. Okay, so you just note down that kind of things also. This is one of the best important information for this the DFS. So for example, if you consider this graph, so A, B, C, D, E, F, and G also. So you may have the graph levels. So one is this A, B, E, C, F, G, and D. So from this graph, A is an initial state. Okay, so A is an initial state. Okay, and D is an the destination or the goal state. Okay, so suppose if we are able to find out the solution, so how we are going to here we are using the stack data structure. So if the searching process has to be expanded or it has to be performed one up to the one depth of the node. So here the node, suppose if we are taking the node A, so we may have the two options. One is B and E. So again, B can be expanded further. C can be expanded as D. So again, the goal node is D is reached now. So again, we can come to this path E. E has F, and there is no more path. And again, we can go back to the previous position as E. So again, we just come to the node as G. So so we need to find out this uh, of the position. So you just note it down. So what are all the examples if you are following on this? So for example, first you just push the element on the top of the stack A. So either you just check it pop A and is it goal? So if you are no, there is again push the children's or the successor on the stack. So what about the successor of A is B. So B is an reason here you just see this B and E. So B is the top of the node, and so again you need to find out B is an goal node. So it is not there now. So again we need to push it on the children's of B. So C is there. So again C is the goal node. No. So again, what is the successor of the C node is D only. So again, we just push it on the stack. So we need to find out whether it reaches the goal. Yes, we reach the goal. We can stop it here. Okay, so this is the way we are able to find out the solution for the depth first search. Okay, so this is one of the best simple example. You just note it down. And this is a explanation of this the depth first search. So next one thing is what are all the advantages and the disadvantages of the depth first search. So first one thing is what is the advantages is a simple this is a very simple method to implement in the any one of the programming languages. And another one more thing is needs relatively very small memory for storing the databases or data search space or the state space also. So needs a very relatively small memory for storing their the state space. So this is two different two important advantages for the DFS the process. So this is the first one. Another one more thing is disadvantages. So what are all the disadvantages of this? That is here we cannot find the solution in all the cases. So it is not possible at all. So we cannot be able to find out the solution in all the cases. Another one more thing is next second one thing is not guaranteed to find an optimal solution. So we are not able to find out then we are that is not guaranteed to find an optimal solution. So we need to find the solution whether it should be an optimal or not. And this method does not provide any guarantee for finding the optimal solutions also. Another one more thing is takes a lot of time to find out the solution on that. Okay, so these are all the some advantages and some other disadvantages of this the depth first search. So you just note down that kind of things also. So so first one thing is what do you mean by the depth first search? Okay, so you just note it down. So in what way the depth first search is deviated from the that is breadth first search. So what kind of data structure has to be utilized for implementing the DFS? Another one more thing is what is the concepts. So you just check the programming that is the concepts. That is if the initial state is in the final state, then success and exit. Suppose if you are not till do it to you get the success or failure. Na? So again, we need to find out the or generate the successor. If no more successor can be generated for this the process generated, then failure. Another one more thing is go to the step one with the initial state. initial state, the currently generated successor. Okay, another one more thing is what is the way we are able to find out the solution of the target node, and what are all the steps that has to be followed for the simple examples. Okay, you just note it down. Another one more thing is what are all the advantages and disadvantages of using this the depth first search the process. So one is the main advantages is there's a simple to implement, very simple to implement for this, and needs relatively very small for storing there the state space. So this is an advantages. So what are all the disadvantages are? So we cannot find any of the solutions in all the different cases. Another one more thing is not guaranteed to find then optimal solutions also. So we are not able to get the optimal solution for this the process also. Another one important aspect is takes the a lot of time to find out the solution for. So that's all about this the disadvantages and advantages of this the DFS process. So you just know. Thank you.